Hey everybody, this is Larry. This is me going Q4 of the weekly contest 464 maximum wars destroyed by robots. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, or this problem. I think this one honestly is not super bad. I think there are a lot of constraints set in this problem that makes it so that it actually is easier. There's a lot of reading for sure, but yeah, let me draw it out real quick. The idea here is that, okay, well, you have a number line. You have some robots. Maybe that looks like a human actually. I don't know. What's a robot? Is that a robot? Okay, fine, right? And then yeah, maybe don't kill that human. But then you have like some walls, and then and they could be on top of the robot for a reason, right? And you're able to shoot, and each robot is able to shoot left or right, and that's it. The key thing to note is that there are a couple of things. One is that you cannot shoot past the robot, so that already eliminates a lot of things, right? Because then that means that for every state, for every robot, rather, maybe start with that, for every robot, it can only interact with the previous robot and maybe, well, you know, the previous robot and maybe the next robot. So that's the key thing, and really that's all I needed, because then now you can define a state in which it shoots either left or right. It's almost like one of those robber problems or whatever. It's just that, yeah. And the hard part about this one may be to keep track of states, right? But honestly, not really, because then now you only have to keep track. In terms of implementation, you can think of it a number of ways, but honestly, they're all similar. In that it's just that given you're now currently in, let's say you're doing DP, you had this robot, and then the only question is whether the previous robot shot left or shot right. If it shot right, then you have to do some math with the walls, right? And because if it shot right and you shoot left, then you have to do some math. If you know, otherwise you shoot right, and if you shoot right, you have to like make sure that the left knows so that you don't kind of intersect the same walls more than once. So stuff like that. But conceptually, that part is just implementation, right? The idea is still going to be the case. Is whether what robot you're looking at now, and you know, because you can't shoot past a robot, you only have one interaction with the previous robot, so it's just about whether the previous robot shot or not. And that's kind of the way that I implemented this problem. Yeah, actually, right. First of all, this one is very weird. I didn't want to take the risk, so I sorted the walls and I sorted the robots. I put the robots and the distance that they can shoot together, so that, you know, so that I can sort them really by the X value, and they're all, I think they're all unique. I could be wrong, but that's basically it. Here's the dynamic programming starter. We started the current index, and this is left. And what is left, right? Index is just the robot we're processing, if you will, and then left is if the left boundary of the walls that we can process. And this can be interpreted a number of ways. It means that in that it is either, I don't know why they moved with me. I don't want it to move with me. The old one didn't move with me. Which is that it can be that the left robot, the previous robot, shot right, pushing the boundary, right? And what I mean by that is so that you don't double count. And maybe I skipped that part a little bit, but because we saw on wars, it's very easy to count how many wars are within just any segment, right? Because it's just two binary search, one for the left side, one for the right side, and then you get the delta, and that gets you the number of things. So yeah, so then now it's just about, okay, well, we want to actually, let me just draw it out, hang on, right? So basically the idea is that, okay, changing colors, yeah, okay, changing, so you have this robot, you can shoot to the left some distance, right? And then the question is, okay, let's say we're given this distance, right? If the previous robot already shot and it goes to here, say, then now we just do the math on the number of wars in this distance. So that's kind of it. That's what I mean by left boundary. Pretty, I hope it's straightforward. But yeah, that's what the left is. And if it's not shot, then we just stop it at the robot, right? The previous robot. That also makes sense. So then you can't shoot past the robot, right? But yeah, then we set left just to the previous robot plus 1 or something. So yeah. Keeping the note for this one is that every robot also owns its own space that it stands on. And what I mean by that is because apparently you could have a wall where the robot is. I don't know how that works if shooting left or right is inside the walls. I don't know, Leetcode is weird. But in any case, but because every robot shoots at least once, it will always hit the one at its own location, so you don't have to worry about other robots interacting with that particular wall. But yeah, but basically I break this down to shoot to the left and shoot to the right. Yeah, if we shoot from to the left, we shoot from robots in the current position and then the distance, right? So that's basically it. I mean, but we also want to keep push the boundary to the left, which is the input. So this gives us left B, which is the left boundary. And yeah, and then now we do recursion. We go to the next robot. We set there because we shot left. The next robot's left is just going to be this current robot's position, but 1 to the right, so that I don't get shot. Or maybe you do get shot and you just get stopped. I don't know how it works, right? And that's basically it. Just keeping track of the states. And this part, I'm not going to go over too deeply, but it's just binary search from the left boundary to the robot inclusively, and this gets the number of wars within that span. Pretty straightforward. Yeah, and then the same thing to the right, but a little bit different, right? The right boundary is just going to go all the way to the right. If there's a robot to the right, we'll make sure that we don't shoot past the robot. I mean, I think it's like example 3 or something. So otherwise, I would have gotten a wrong answer. I'm not gonna lie, I forgot about that case. But yeah, but it is an example, so I caught it. But basically, it just makes it so that you cannot shoot past that place. Yeah. Otherwise, then now, well, we already shot to the right, right sub B, right boundary. So we just move 1 more so that we cannot shoot to the right B inclusive. I did have a typo that gives me a plus. That gave me a +5 minute penalty, wrong answer. And this is just a regular binary search. I mean, same thing as we talked about, right? 2 binary search to get the number of wars. The indexes will give you the number of wars, and that's it. That's the entire function, right? This one may look confusing a little bit in terms of the way that I wrote it, in terms of complexity analysis, but index 0 to n. Hopefully that one's straightforward. Left. Well, there were only 2 possibilities, right? If the previous robot shot left, then it is just the previous robot's position, whatever, the position, right? I'm gonna write it in. I mean, this doesn't map to my code, but the position, right? But that position, maybe that's a little bit cleaner even. And then yeah, if previous robot shot right, then it's just gonna be robot index -1 plus robot index -1 dot distance, right? Something like that. I mean, this also gets capped at the current robot's location. It's not a formula, but my point there is that left can only be 2 different things. I mean, I draw it out a little bit. It's not 100% precise, but it can only be 2 things is my point, right? Because this can be capped, sure, but it can only be 1 or 2. So this means that the number of inputs, or the number of distinct inputs or states, as you sometimes call it, it's going to be n times 2 or O of n. And each input does 4 binary search up, right? I mean, you just look at it. I don't think there's any hidden things about it, right? Which is O of log n, or log w for wars, maybe. I guess the number of wars is not the same. But in any case, there's going to be O of n log wars, and that's it. Plus, I mean, that's for this function. Of course, you have to do some sorting first, so you can say, maybe if you want to add them all together, it's going to be n log n plus w log w plus n log w, right? I mean, that part, I think you know how to add stuff. But yeah. right? And that's it. Space is linear, right? Linear, 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 and that's it. That's all I have for this one. Yeah, that was pretty okay. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health, and you can watch me solve a live in contest now. Re Problem setting. That's like a very ambiguous problem. That's really bad, actually. Okay, so we have half an hour. Can I get this? How does the ranking look? If people got it, well, okay. I always forget that there are a lot of cheaters. No one I recognize on top, so that's not a good sign for me. I was hoping that someone got it really fast. That means that I could maybe do it slower, but still fast. We have half an hour now, so let's get started. Well, okay, so we have robots, distance, war, right? Robots, eye position, okay. What does that mean? Okay, straight line, so 1D axis. Distance of eye is the maximum distance eye. But what? Where does the bullet come from? They just dropped that here. Anyway, yeah, maybe you should talk about this part first. Each robot has a bullet or something. Okay. Anyway, robot can shoot a bullet and there's a war. Okay, every bullet can one bullet. They can fire to left or right at most distance of eye meters. Okay, I mean I guess that's what this part is saying. Though they wrote in a really weird order. A bullet destroys every wall in its path, and like, okay. Robots have fixed obstacles. If a bullet hits another, it immediately stops at that. Robot cannot continue. Okay, so you could destroy walls, but not robots. Okay, a very weird bullet, but anywho, maximum number of unique walls. Okay, so it's almost like some sort of I don't know, whatchamacallit, like I don't even know anymore. I think it's DP though, probably, because just DP on right is left or right on the left. Because you can't shoot past a robot, so well, okay, so what does unique walls mean? Does each robot get to shoot once? Oh, has one bullet. Okay. Okay, so we was here. So we have a robot at 4, and it's just maths, right? Binary search, maths. I assume walls are sorted, but maybe I just sorted anyway. I don't know. I mean, actually, maybe you can assume that, even though that is really silly. But robot sorted. I guess robots are also maybe not sorted, so let's just sort it. They are unique though. Okay, so then yeah, I mean, I don't know. Right? I mean, I think there's just DP, right? I don't get it. DP, maybe binary search. I mean, maybe both is what I mean. There are really only 2 states, whether the pass robot shot or not, right? If it's shot to your direction, then whatever, right? I don't know. Shouldn't be that bad, maybe. I don't know. But I feel like if it wasn't that bad, then more smarty pants would have gotten it. Still trying to find someone I know, but not finding someone I know, it's a little bit awkward. TS Reaper took 20 minutes. That's not a good sign for me. If it's someone that smart took 20 minutes, and I only have 20 minutes left. 27 minutes. Okay, but we have index robot. We have to maybe how do they shoot or not? We can also just say I don't know, left side as in the walls that they destroyed, and unless I'm misunderstanding this problem a little bit. And then that's it, right? And the left is, I mean, left is a big number, but it actually is just 2. Is whether it just controls whether the robot, the previous robot is short or not, because it doesn't extend, right? So index is equal to n, then we just return 0. Otherwise, then yeah. If okay, so now we have, and we always want to shoot. So shoot to the left, shoot to the right. So this is not quite a take no take fit. Best equals 0. We already sorted was, so we want to shoot was from robots of index to robots of index minus distance of index, I suppose, right? That's I have to mess this up because I yeah because I sorted robots, but I have to move. Yikes. Rx and then our distance, insert robots distance, right? Something like that, nothing too bad, right? And then now we want to, yeah, I mean that's fine. It's gonna be n log n. There's just a lot of binary search. To write that, that's fine, easy to write. So, robots minus distance, so shooting left, so you either go to left boundary, is you go to either the left boundary or robots, right? Pretty straightforward. And then now it is going to go index +1 left. No, the left boundary is now at robots r of index plus of 0 plus 1, because you don't want to shoot the robot. I mean, there's no wars at the robot, right? I guess that's not actually clear. No, there's a war at the robot. How do you even, how does that work? This is a very poor farm. Why would you put wars and robot at the same place? What does that even mean? Like, can you say if it goes left and right? It's very weird. But in any case, it should be fine because that will, this robot will get it. So then we'll just set to +1. And also I have to write r index of 0 minus r index of 1, right? And then this is this plus the number of rows. So that is just going to be the binary search. Do I want to save this? I mean, I think no. I mean, we could probably cache it, but it's not. I don't think it's a big deal. Bisect left of the rows from LB all the way to. Oh, so this is and then bisect right was our index of 0. Right, so subtract this, that's the number of unique rows. I think we should be good for search. Right, okay. Return best, oops. And return go 0, robot sub, no, negative infinity. Alright, I mean, I know that this isn't done. We haven't shot to the right, but I just want to see if it gets things right. Can I access left B? Oh, yeah, of course. No. I mean, well, yes, this part. Okay, there you go. Okay. I mean, we only shoot left. What does that look like? 1, 3, and 0. Somehow that all the inputs are only shooting left. Thanks, Leetcode. You are useless. But anyway, okay. So then otherwise shooting to the right, we should skip to the 1. The new left is going to be, so we shoot to the right, then we have everything inclusive of so we want to +1 it so that it doesn't double count it, plus, and then now we can bisect. We want to go from this to bisect left of rows of index of 0, and I think we should be good. Hopefully 1, 3, 1. Okay, well, shooting right apparently made this no Gucci. Oh, okay. I have to. Okay, I didn't do the. I was like, that's a bad wrong answer, but I forgot that it cannot shoot past the robot. That's actually pretty good, because then yeah. Oh, that's a pretty good example, because I actually forgot. Okay, so then left boundary in this case is equal to, also if index is greater than 0, then it cannot go past the robot to the left, which is going to be R of index of, or index of -1, the position, right? So yeah, okay. Is it +1? I guess it doesn't matter if it's no, we should make it +1, because you don't want to shoot past at the robot, because I think the left actually takes care of it, so you cannot shoot past on the left side anyway. Okay, I don't think we need this, because that's what the left side is for. The right side we don't take account, and our assumption is that, okay, fine, right boundary is equal to f min of this number, or well, I guess it's just this number first, and then if index +1 is less than n, then right b f min of r index +1, the location. Right? Not inclusive, so we have to be careful. That's what I'm trying to think. Okay, I think that's right. Then now this is just, yeah. Maybe, hopefully. Oh, I forgot to do the f min. If it looks good, I'm YOLOing. We have 18 minutes left, so we don't have much time to kind of think about it. Yeah, okay. That's a little bit sad, honestly. Because I was hoping, but the fact that we shot more rows than expected means that actually maybe our logic is still right, but there's an implementation error. And it's probably on the right side, I wouldn't say, but maybe not. Maybe I haven't given much thought on the left side. Left side should always index +1, right B. No, this should be always be at least, even if this is 0, should be okay. So that should be set correctly. And because the only interaction is in between, so there shouldn't be any more states. Left side, we want to be inclusive if we can. Yeah, no, left is always +1, so we always keep track of that. Is it though? We shoot to the right. Oh, why is this a +1? I think +1 is what okay, so maybe that's why. Okay, that would be good if that's true. That's how much we shoot, but the boundary is +1. I think that's the thing. Okay. Yeah, maybe. Let's see. Alright, I mean, it fits for this one, so maybe I did actually just copy and pasted wrong, for sure. Okay. I mean, we actually did this one faster than some. Oh, Alex actually did it. I mean, Alex is Alex. I don't. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about each problem, this contest, everything in between. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye bye.